All right, now we're on to the second method for solving systems. So we already practiced substitution and how that works. Elimination is the second one. There are a couple other names for it, but elimination to me makes the most sense. Elimination is going to be best used when you are in standard form. So standard form, just to remind you what standard form was something like 2x plus 5y equals 8. Something like that, where you have your x's and then your y's and then your equal sign and then your constant. When things are in standard form, it is way easier to do this process with what's called elimination. The goal is to get one of your columns, when you look at your x column and your y column, to have opposite coefficients. Here's what I mean by that. If this one down here looked like this would be a great one to immediately do elimination because the x column has opposite coefficients, meaning one is positive 2x, one is negative 2x. What is completely ideal about that is it allows that entire column to cancel or be eliminated whenever you add the column together. That's the perfect situation whenever it's already ready to go. The ones that aren't quite ready to go, you have to do a little manipulation with. The goal is to figure out what could I multiply one of the equations by in order to get opposite coefficients. So sometimes it's not quite as immediate and it takes a little extra work. Once you do that, you're going to add your columns together and that will give you one variable. You will then use basic algebra to find the next. So let's go through and do this. So we're going to start with a super easy one just so you can kind of see like the different levels of difficulty. So the reason this one is super easy is because the x column is already ready to eliminate. Because if you notice, the 3x and the negative 3x are opposite. So that whole column will cancel. In your y column, when I'm adding vertically, I have a negative 4y and a positive 4y and a negative 2y. When I add that column together, I get 2y. And then I have a 9 and a minus 3. When I add that column together, I get 6. So I get y to be 3. Once you're done finding one variable, keep in mind you do have to go back and find the other. In this case, you can actually use either of the original equations. It's totally up to you. Sometimes one of them may be simpler. Sometimes one of them is just the first one your brain goes to. I'm going to put it up into the first equation. So I have 3x plus 4 times 3, because that's what I just found y to be, equals 9. Well, 4 times 3 is 12, so I'm going to subtract 12 from both sides. So I have 3x equals negative 3. Divide by 3. You get negative 1. When you write your answer, you always want to write it alphabetically, x and then y. Even though we actually found the y first, you still want to write it in the correct order, x and then y. So that's the easiest case. Sometimes they won't be quite as easy. You'll look at one like this number 4 that you have here, and nothing will automatically eliminate. None of the columns are opposites and will cancel. So it's going to take a little bit more work on your end, and the work's going to be figuring out what I could multiply by in order to get things to eliminate. So if you look at this one, and most of these can be done many different ways. I'm going to try to show you the way that's maybe the simplest or the most obvious. With this one, the best way to do this one is to multiply this entire second line by 3. The reason is when you multiply the y value by 3, 3 times negative y will be negative 3y, and then it will cancel this column. I'm not going to do anything to the top line. I'm just going to rewrite the top line so we have it here. But the bottom line, I need to multiply everything by 3. So when I do 3 times 5x, I get 15x. When I do 3 times negative y, I get negative 3y. That was the goal. When I do 3 times 13, I get 39. Now I can go through and do this because my y's eliminate. I'm going to add my x column. 2 plus 15 is 17. I'm going to add my constant column. 12 plus 39 is 51. And I'm going to divide by 17. You get 3. Once you know what x is, you need to go back and find what y is. So I'm going to put this 3 back up into this top line. So I'm going to have 2 times 3 plus 3y equals 12. 2 times 3 is 6. So I'm going to subtract 6 from both sides. I get 3y equals 6. So divide by 3. Y equals 2. I always want to write it in alphabetical order. X comes first and then y. And again, your answer represents where these two lines intersect. It also represents the x and y value that you could plug into both equations and make them true. Next one is probably the highest level of difficulty here because there's not a real quick fix. It is not one that we can automatically eliminate. It is also not one that I can just multiply one line by something and get it to eliminate. So in this case, I actually have to do kind of a double adjustment. I need to multiply the whole first line by something and the whole second line by something different in order to get it to eliminate. You have choices here. One thought, you might be looking at this going, well, what if I got the x's to be a 6x and a negative 6x? That would be great, quick multiplying. Some people might look at this and say, no, I'm going to work with the y column. Let's get the y column to be a 20y and a negative 20y. Also works. As long as you pick something that will eliminate a column, there are many ways to do these. I'm going to get rid of the x's. So I'm going to multiply this top line by 3. That will make your x's 6x. And I'm going to multiply the bottom line by negative 2. That would also get that one to be a 6, but it would be a negative 6x. So when I multiply the top line by 3, I get 6x plus 12y equals 30. Just make sure you multiply correctly. And then when I multiply the bottom line by negative 2, I get negative 6x, negative 10y, and negative 22. By doing this, my x's have been eliminated. My y column, I have a 12y and a negative 10y would combine to give me 2y. And I have a 30 and a negative 22, which would combine to give 8. So I get y equals 4. I have to go back to one of my equations to figure out x. I actually have a lot of options here. My advice would be go back to one of the original equations. That way, if you made a mistake on one of your updated equations, you won't cause as much of an issue. So I'm going to put it in the very top equation. So in the top equation, I have 2x plus 4 times y is 4 equals 10. 4 times 4 is 16, so I'm going to subtract 16. I get 2x equals negative 6. So I get x equals negative 3. So my coordinates, my ordered pair is negative 3, 4. And again, that's where they intersect if you were to draw them, and it's the x and y value that makes them both true. So the last thing we have to do is look at a couple special cases. So our special cases are going to be one where something kind of odd happens at the end. And I'll show you what happens with these so you understand what to expect with our special cases. First thing you're going to notice is you do have parentheses here. That's not necessarily what makes it special, but it is a little different. So I'm going to keep my top line the same, but I do need to distribute before I can start figuring out what I need to do here. So I'm going to distribute the 2. I get 6x minus 2y equals negative 8. Well, the first thing you notice, so maybe you notice a couple things, is we don't have to do any adjusting with this. We have columns that eliminate. The second thing you might notice is every column eliminates. My negative 6x and my 6x cancel, my 2y and my negative 2y cancel, my 8 and my negative 8 cancel, which means I have nothing left on this side and I have nothing left on this side. So this is our first special case when everything cancels, your x's, your y's, and even your constants. When that happens, you are left with 0 equals 0, which is always, always, always true. So this has infinite solutions. That's one way to write it. Or you can say it's all real numbers. What this means is these two are the exact same line. If you were to graph both of them on a coordinate plane, they would be right on top of each other because they are completely identical. So now with the next one, I'm going to distribute a lot here. I'm going to distribute the 4 through and then the 2 through. So when I distribute the 4 through, I get negative 12x plus 4y equals 10. And then when I distribute in the bottom one, I'll get positive 12x, negative 4y equals 8. Couple things that you should notice. First of all is we don't have any extra work here. Things are already ready to eliminate. Second thing you should notice is all of your x's eliminate, all of your y's eliminate, but your constants don't. So when that happens, you're going to have everything gone from the left side. So you're going to put a 0 there to show that everything's been eliminated or canceled. And on the other side, 10 plus 8 equals 18. In this special case, you're going to end up with something at the end that is nonsensical. 0 will never equal 18. All my x's are gone, all my y's are gone, so I get 0, but my numbers aren't. So I don't get something that's always true. Instead, I get something that is never true. Or you can use my favorite symbol, the circle with a line through it. What this looks like, these two lines are parallel because they will never intersect. So those are your two special cases. We tend to see them the most when we are working with elimination. So those are your two techniques. We have the substitution method, we have the elimination method, and that's how you solve without having to graph.